This is coal. Here in the United States, it's the most abundant, accessible, and reasonably priced fuel available for generating electricity. Each and every day, millions of tons of coal are mined and shipped by barge, rail, and truck to utilities throughout the world to help satisfy our global reliance on electricity. Many power companies, including American Electric Power, rely on coal to fuel the power plants that in turn have fueled the growth and development of our nation's economy. Here in the United States, coal is used to generate roughly 50% of the electricity that we consume. But a new reality is affecting our view of fossil fuels, including coal, and their future role in making electricity. Scientific evidence points to a link between increases in greenhouse gases in the atmosphere and changes in the world's climate. Burning fossil fuels, such as coal, releases carbon dioxide, one of the major greenhouse gases. So the challenge for AEP and other generating companies is to develop new methods and technologies that will allow us to continue using coal and other fossil fuels as an energy source while reducing its impact on the environment. Which brings us here to AEP's Mountaineer Power Plant near New Haven, West Virginia. This is one of the locations where AEP plans to demonstrate new technology that will allow us to capture and safely store carbon dioxide from our power plants. This validation will help pave the way for a broader deployment of the technology on other power plants in the future. AEP's research into the storage of carbon dioxide started in the early 2000s here at the Mountaineer plant.
Yeah, back in about the 2001 timeframe, the Department of Energy worked with a number of groups, including Battelle, to form regional partnerships to study geology in the country, looking for and anticipating an eventual need to store CO2. They were looking for geologic characteristics of the certain areas to make sure that you could effectively store CO2. So Battelle came to AEP knowing that we were a large source of CO2 in the area and asked if we could offer up a host site where they could study the geology and ultimately do some drilling and get an idea of the capacity and viability in the area for storing CO2. They brought a drilling well and they drilled from surface down to about 9,200 feet below the ground, which is all of the different sedimentary rock layers. And they discovered that in that they had all the requirements to store CO2. The first requirement is that you need containing cap rock that would hold anything you put down from coming back up. And so they identified literally thousands of feet of containing cap rock, shale layers that are impermeable, that would hold anything that would otherwise want to come to the surface. The second piece is they were looking for storage areas where they could put the CO2, and they identified a couple layers that are fairly thin, not thousands of feet, but hundreds of feet thick, where CO2 can be stored. And identified those two key characteristics and determined that it was a great site for storage of CO2. We started then to look at the capture side. How do you capture CO2 economically? And we got in contact with Alstom and found out that they're developing a technology that does the capture part, remove CO2 from the power plant.
In 2007, AEP announced plans to invest nearly $700 million to explore, to validate, and ultimately commercialize a process for capturing carbon dioxide developed by Alstom Power Incorporated. It uses what's known as the chilled ammonia process to remove the CO2 from the exhaust gases. The actual capture process occurs in 3 steps. First, flue gas leaving the boiler is chilled to about 40 degrees. It then moves to an absorption module where the carbon dioxide is absorbed through contact with a solution of ammonium carbonate. The new mixture, which includes the captured CO2, is then pumped to a regeneration system. In the regeneration system, the solution is heated and the absorption process is reversed and CO2 is recovered. Once the CO2 is removed, the ammonium carbonate is cooled and recycled back to the absorption module where the process is repeated.
So we started just having discussions with Alstom about implementing this technology at a very small scale and start testing it and verifying that it worked.
Once the CO2 is removed from the flue gas, a sophisticated injection and storage process will allow the company to store up to 100,000 metric tons of CO2 per year in stable rock formations more than a mile below the Mountaineer plant. The CO2 is compressed into a liquid-like state and injected under pressure into carefully chosen geologic formations. There it is permanently stored in rock formations thousands of feet below water tables and drinking water supplies. The targeted storage formations consist of permeable and porous rock where the injected CO2 spreads through the pores in the rock, much like water fills a sponge. The CO2 is effectively trapped from moving upward by layers of very thick and impermeable caprock that lies above the porous formations, much in the way oil and gas deposits have been trapped for millions of years. Scientists from the Battelle Memorial Institute have done extensive research to confirm that the deep formations below the Mountaineer plant are suited for permanent CO2 storage.
We're working with Battelle on the storage piece. We're working with Alstom on the capture piece. We'll have a 20 megawatt scale slipstream in place by September of 2009.
AEP will be working with Battelle to develop monitoring and verification programs to ensure that CO2 remains in place indefinitely. We've described one major research project that AEP is working on to help reduce the amount of carbon dioxide our plants release to the atmosphere. But that project is just one part of a much larger effort we're making to minimize our impact on the environment. For instance, we've made voluntary, legally binding commitments to reduce or offset a total of 46 million tons of CO2 by the end of 2010. We're making efficiency improvements in our existing power plant fleet that will have significant effects on carbon emissions. We're advancing the commercialization of a new generation of power plant technology, including integrated gasification combined cycle plants and high-efficiency ultra-supercritical pulverized coal plants that will allow us to continue using coal to generate electricity in a carbon-constrained world. And we're equally involved in the development of alternative sources of energy that can replace traditional fuels or postpone the need for new generating plants. AEP is working hard to balance its obligations to its customers, its communities, and the environment. To learn more about AEP's environmental stewardship and corporate responsibility activities, visit us online at aep.com. You'll find a wealth of information on our efforts to lead our industry forward to a brighter, safer, cleaner future.